We're delighted to have both Brian McGahan and Richard McLean from INE, who are going to be doing the majority of the session today, looking at using VIRL for CCIE preparation. So looking forward to a good show from Brian. No pressure, Brian.
Thanks, Joe.
We've also, as existing VIRL customers may have seen, and those of you who subscribe to the VIRL newsletter, we're really happy to announce a new version of VIRL that went out last week. So a bunch of new features, new functionality that's gone in there. So we've got new software automation, software upgrade automation framework, some really neat real-time traffic visualization pieces, a nice new function within the live visualization, so syslog data export, so you can get all your syslog messages, pull that out, chunk that through Excel, or dump that into Splunk. But also very exciting, we just pushed out yesterday VIRL on OpenStack clusters. So we've had clusters available for a little while on the Packet platform, and Brian's going to be talking about the Packet platform a little bit today. But now we've got the ability to run VIRL across multiple computers at home. So if you've got some machines that are sitting around, obviously you have to be capable of running virtual machines. Yes, now we can bring all that compute power together to run some larger, more interesting simulations than you've been able to do previously. So really, really happy to get that out there. Hopefully you'll have seen there's a video that's accompanying that, which will show you how all that functionality is working. Okay, I'm going to hand over to Brian, and Brian, ready for you to take it away.
So first, I'd like to thank Joel and the VIRL team for having me here today. As Joel mentioned, my name is Brian McGahan. I'm a 4-time CCIE and CCDE. I'm an author and instructor for INE, where we focus on CCIE training. And in today's session, we're mainly going to focus on how you can use VIRL on the cloud, specifically on Packet.net. And we're going to talk about how to launch VIRL on the Packet.net instance, how to clone the INE topologies. So if you're doing CCIE preparation, how you can go through some automation to kind of speed things up. And then we'll talk about how to launch and manage the topologies. And then towards the end of the class, go through a Q&A session. So you'll see that one of the kind of hurdles for this is that the learning curve is kind of high for the initial deployment of this. And basically, I'm going to walk through step by step how all the components fit together. And then you'll see once you go through it a couple times, it does become much easier once you get used to the process. So first and foremost, in terms of what do we need to begin with, is you need a VIRL license key. So if you see the link there, ine.co/VIRL. VIRL team was nice enough to give us a 15% off for those of you that don't already have VIRL licenses. Also, you need an account on Packet.net. Packet.net was also nice enough to give us a $20 free credit for anybody who signs up, which ultimately works out to be about 60 compute hours. So if you're not 100% sure if this is going to work out for you, then I would recommend to try it out. Nothing really to lose in terms of the initial deployments. And then last and not least, you need the VIRL box cutter virtual machine, which is hosted on GitHub, and we're going to go through here specifically what are the individual components of that and then how we actually launch the process. So beyond this, in terms of other software packages that you need, we need to basically launch the VIRL box cutter virtual machine, which is going to run in VirtualBox and Vagrant in my particular example. So Vagrant basically being like an automation and orchestration type software. And then once we do some initial setup in terms of assign our VIRL license, assign some basic settings, then most of the work is going to be done automatically behind the scenes through the automation that Joel and the VIRL team has written to talk to the Packet.net servers. So again, you'll see from an initial deployment, there are some kind of hurdles that you need to get over, but once you get past that initial deployment, then beyond that, it's fairly easy to actually automate the process. We'll also see that some other minor software packages we need, like an SSH client. So of course, to open the CLI, like to the actual VIRL machines, and also to the Vagrant virtual machine. We'll also need an FTP client, a secure FTP client. In my case, I'm going to be using FileZilla on Windows. An open VPN client that is ultimately going to privately connect us to the VIRL Packet instance. And then the Git client, which is going to be used to download both the VIRL box cutter files, and then also the INE topology files. But as you guys will see, this is kind of an optional step here. Then last but not least, once we have the topologies actually running, I'm going to show an example of using the User Workspace Manager, or the UWM, to directly launch the topologies and to manage them, and then also using the VM Maestro desktop client that most of you are probably familiar with already. If you've already run VIRL on your laptop or some sort of server internal to your organization, where typically that's where you build topologies, where you manage them and then launch your CLI instances. Okay, so once we have the basic things together, next thing is that we need to look at what are the individual steps to deploy the actual box cutter. So if you go to the GitHub page that the VIRL team has put together, they have a fairly complete README here that walks you step by step through the entire process. So up to this point, we're assuming that we already have a Packet.net client, or excuse me, a Packet.net account, that we have VirtualBox installed, we have Vagrant installed, and we've gone through the other basic steps of installing whatever the software packages that we need up to this point. Okay, past that, then we're going to log into Packet.net. We're going to generate an API key. This is going to be used for basically authentication between the orchestration of the Vagrant locally, the Vagrant virtual machine that you're running on your laptop or your desktop, and then the remote Packet instance that ultimately is going to run VIRL. So in my particular case here, let's go ahead and connect over to Packet.net. And I already have an account created. And in this case, I actually already have the VIRL server provisioned here. And you'll see specifically why is that it's a fairly time-consuming process to actually get the orchestration to spin the bare metal server up. So down the road, when you're actually using this for your studies and your preparation, you want to plan a little bit ahead. You know, maybe in the morning, send off the orchestration, have it start the process, and then when you come back about an hour later, everything is going to be ready for you to actually get onto the VIRL box. But assuming that the instance was not already deployed, we would go here under API keys. You just generate an API key, so click the little plus button. You can call it whatever value that you want. Okay, in this case, I have one that's called VIRL on Packet. Next step is that assuming we have the other software packages installed, which are VirtualBox, Vagrant, and then in this case, the VirtualBox Vagrant plugin. And next, we're going to clone the VIRL box cutter Git repo. So if you follow this link here, the same one that was on the README, and you go up one level under VIRL box cutter, you can either use this URL here in your Git client in order to actually copy down the repo, or if you want to skip over that, and like I mentioned, technically the Git client is optional, you can just here over on the right, just click on download the zip, and then it's going to download the files to your local machine. Now ultimately, once you have these open up, there's some minor other things that we need to change inside of the VIRL box cutter repo. Mainly these are going to be relating to your individual VIRL license key, the API key that you created from Packet.net, and then some other minor settings that you can customize. So in this case, particularly here, if we go to my Windows CLI, I'm under the directory where the VIRL box cutter Git repo was open. And there's a couple files here. One is settings.tf, the other one is id.conf. And then under the directory that is salt, this is where your VIRL license key would be, your private key, which is the minion.pem. Now, a couple of the important ones about these settings under the settings.tf, this is where your API key is that you generated from Packet.net, so you just copy and paste that string into this particular value here. Then the other one that's important here is a setting that's called the dead man's timer, which basically by default, after 4 hours, the automation is going to tear down the bare metal machine that you have provisioned on Packet.net. So it's kind of like a last-ditch protection mechanism that if you forget to turn the machine off, that you're only going to be billed for 4 hours of usage on the Packet.net service. In my particular case here, I increased this to 8 hours. You can technically set it to whatever you want, but if you remove this field here, then it's going to just continue to run the server until you ultimately manually tear it down. Okay, there's a couple other settings here, like what's the physical location or what's the physical data center from Packet.net that you want to use. This field here is referring to New Jersey in the US, which I think is the default value here. And then you can customize these other options, which are likewise talked about in the README for the VIRL box cutter instance. The other ones that are important here under id.conf, this is going to be your VIRL user ID and then whatever the domain is. And then, like I mentioned here, minion.pem, this is going to be your actual private key in terms of the actual VIRL license. So once we have all those files together, this is going to be just from the very first time deployment, so you don't need to regenerate these files or regenerate the keys every single time that you want to launch. Once we get up to this point, then we're going to start the Vagrant box and then tell it to actually spin up the automation on the packet.net side. Specifically, the way that we do this from the CLI is to say Vagrant up. And in this case, as I mentioned, I already have the box provisioned, so if we just scroll back in my history here, it's cut off a little bit at the top, and basically this is it downloading the Ubuntu install, which is ultimately going to be the Vagrant virtual machine. And then once everything is done here, what you should see is that it's going to start to listen on your local machine at, and I'm not sure if it shows it here, but it starts to listen at port 2222. So 127.0.0.1 being your local machine, your local loopback, and the username and password for the machine is going to be Vagrant. So from there, you can either say Vagrant SSH from your CLI, or you can open up through whatever your other SSH client, like in this case, I'm using Secure CRT. Basically, we're just connecting to the virtual machine that's running local here on my desktop. So point being is that the Vagrant box is not the one that's in the packet cloud. The Vagrant box is the one that's local on your laptop or your desktop, basically whatever machine that you're running the deployment scripts from. Now inside this VM, it'll start inside the Vagrant user's home directory. So if you cd to VIRL_packet, you'll see some of the other settings here, like the variables.tf. If you look through some of these other files, this would be if you want to customize your specific deployment, like if you want to change the guest password or the admin password for what is actually going to be used on the VIRL instance. Most of this stuff, though, you don't really care about, to tell you the truth. That once the automation is complete, it returns what is going to be the IP address of the remote machine, what's going to be the guest username and password, and then you can just basically copy and paste that string when you actually go to log into the web interface to deploy the topologies once the VIRL machine is actually up. Okay, next step, once you get to this point, that you're on the Vagrant box, so you SSH in, log in as Vagrant and Vagrant, username and password. Then under the VIRL_packet directory, you say terraform plan dot, and then after that terraform apply dot. And you can see here I have the script that is completely run. So it does take quite a while in order to do this. This is basically when it's provisioning the physical machine in the packet cloud. It's doing an install of Ubuntu bare metal on the remote machine. It's downloading all the VIRL packages, and then ultimately booting up the hypervisor and the user workspace manager. Now, the way that I personally have it set up is basically I have a script in Secure CRT that just says when I open this particular SSH instance, it's going to log into the box. So it's going to change to that directory, VIRL_packet. It's going to say terraform plan dot, and then terraform apply dot, which is basically launching the script. Now, this machine here doesn't necessarily have to be your local laptop. It could be some sort of jump box that you have hosted on some other hypervisor, or maybe you have hosted on packet.net itself, that you're basically just saying, I want to create the VIRL instance in packet.net, and then ultimately this is where we're going to manage the VIRL instance from. So once everything is said and done, and the deployment is complete, like I mentioned, it takes normally about 45 minutes, then we're going to open VPN to the VIRL instance. And again, this is one of those other settings that you can control. If you don't want to use OpenVPN, you can edit the settings.tf file inside of the actual Vagrant box, and then tell it, I just want to connect to regular clear text through the internet. But the key point being here is that otherwise your VIRL ports would be open to the public internet. So with the default deployment, it's only listening for SSH from your jump box. So based on that SSH key that packet.net is creating. And then also it's listening on port 443 for OpenVPN, which is basically similar to the Cisco AnyConnect VPN client, which uses SSL VPN over 443. Now, I did get a couple of customers that asked questions about this. They ran into some problems when they were running the OpenVPN client. And I think most of the problems come from this. In the case of Windows, I'm not 100% sure on macOS and Linux, but if you don't run the OpenVPN as administrator, or if you don't run it as root, it's not able to add a route entry to your local routing table, basically to do split tunneling. The idea being is that I only want to send traffic going to the 172.16.11 network, which is going to be the VIRL management address, and then the rest of your regular web browsing traffic is going to go to your public WAN connection. So in the case of Windows here, it basically means that you just need to right-click on the OpenVPN process and then run it as an administrator. But specifically here, the key is that the actual client file, which pre-configures what the IP address is of the packet.net instance, what the username and password is, this is auto-generated through the deployment process onto your Vagrant box. So as I mentioned earlier, one of the things that you also want to have is an SFTP client, which in my particular case here, I'm going to be running FileZilla. And basically what you do is you just SSH to your local box, so 127.0.0.1, port is 2222, so it's FTP over SSH, and then inside of the VIRL packet directory, you can see this client.ovpn. Now from the actual deployment process, what you're basically looking for is that once everything is said and done, it should return this output at the bottom that it says, hey, your OpenVPN client is ready. The public address of your packet instance, in my case, it's at 147.15 or 147.75 address, and then what the internal address is going to be, the 172.16.11.254. This is going to be a static address that is used for all of the deployments inside of the VPN. So essentially what we need to do is then to download that file, which in this case is client OpenVPN. And in this case, I'm just putting it onto my desktop. And then here on my desktop, I have a shortcut to the OpenVPN config directory, okay, which in the case of Windows is under Program Files, OpenVPN config. And basically, I just want to move that client file into there. And then when I actually run the OpenVPN GUI, key point again here is that you need to run it as administrator, or basically run it as root. So once you open the GUI, you should see here that it connects to the remote client. In this case, that 147.75 address, and it should also pop up like a notification that you were assigned an IP address internal to that particular network. So just like any Connect VPN, it's basically a private connection, hence VPN, between you and the VPN server on the other end, which in this case is the VIRL instance. Now, once this is done, the way that you can really tell if this works is just to ping the other end. So if you can ping to 172.16.11.254, that's going to be the VIRL instance that is deployed on the other end. So as I mentioned here, once you go through this process a couple times, the only thing that you need to do for subsequent connections is just to say vagrant up to run your local virtual machine, SSH to the Vagrant box and do Terraform plan, do Terraform apply, wait about 45 minutes for the full deployment to create. SFTP into the local Vagrant box and download the new OpenVPN client, open that up, and then we have the connection to the VIRL machine on the other end. Okay, at this point, everything else is going to look as if we were locally connected to a VIRL instance that's running on your local laptop, running on your local server, etc. As long as you have IP connectivity to that address, which again in this case was 172.16.11.254. Okay, the other key point here is that if you use the default options of the Terraform deployment of the Vagrant box, the guest username is going to be some random variable. So you can see this again when you look at from the Vagrant SSH session. When everything is done, it returns back to you what the guest password is. But if you want to set this as a static value, you can just edit the passwords.tf file and then say that is guest or whatever value that you want. It technically doesn't even really matter what these usernames and passwords are because they're behind the VPN. So if you say guest, user, or admin, et cetera, as username and password, you're not really leaving yourself up to any problems because the remote server is only listening for 443 for the VPN connection, and then the SSH from this local box, which already has the public and private key pairs exchange with the remote server. Okay, so up to this point, we're basically now ready to actually run VIRL on the remote box. So we're going to open up a new web browser, go to 172.16.11.254, and then this is going to return the GUI just like you would see on your normal local VIRL instance. So from here, we're going to go to the user workspace management, and then we're going to log in as guest. And then again, the password here is going to be the one that the the one that it returned here, which is this kind of random string. So I would say that if you're using this persistently, you probably do want to edit the guest password, because also we'll see once we go into VM Maestro and you edit your connection profile to connect to the VIRL hypervisor, you will need the guest username and password listed correctly there in order to manage the topology that's actually running. Okay, so up to this point, we're basically done with the packet deployment process. Okay, so we log into user workspace management. Now we're going to get to the point where we're going to download the topologies. Specifically, in this case, we're going to clone the INE Git repo. And then once that's done, we can go ahead and actually launch the topologies. So specifically, what you need here is this URL, which is the github.com/internetworkexpert/ine-virl.git. Or if you just follow this short link here, which is ine.co/gitvirl. Or if you just go to github.com and search for my username, which is McGahan, you'll see it's one of the only repos that I have contributed to, which is ine-virl. So basically, you just want to copy this particular string. So let me open that up here. Okay, and the specific string is going to be here under HTTPS, so just copy that to Notepad. And then what we're going to do is under the user workspace manager, we're going to add this as a Git repository. So under that separate window that you had under UWM, we're going to go under repositories. We're going to add a repository. Just paste the URL in and then click clone. Okay, assuming there's no network connectivity issues from the packet instance to GitHub, the end result is that it's going to download the entire repo here. And if you click on it to browse through it, you'll see right here, this is where we have the different VIRL topology files for the different labs that we have. Okay, so as of right now, I only have the RNS v5 workbook listed there. But we are in the process of adding the other topologies like Service Provider version 4. We'll have some other options for data center, for security, and for collaboration. Basically, since we're managing the Git repo on our side, there's nothing that you'll need to change on your end when you go to download these files. So assuming that you are refreshing the repository when you actually go to add it, like we just did here, you could also just click this little reload button, and that'll download any new changes to it. So it's going to do a git pull. But under here, then we're going to just choose a topology. Okay, so let's say we're going to choose under advanced troubleshooting. We'll take this first one, lab 1 with broken initial configs. Okay, so from here you can see the actual details of the VIRL file. And the key point about this is that all of the initial configs are already loaded in the .virl files. So once the topology is booted, you don't need to copy and paste any of the configs. It's already going to start up with all of the, in this case, the troubleshooting topology and all of the broken initial configs that you ultimately would need to solve as you're going through these specific questions. Now from this point, we're then going to go up to the upper right and then go to quick launch. You could also go under launch with options if there's any customization you want to do here. For example, if you want to change the management address of the Linux box that's managing the VIRL instances. In this case, I'm just going to leave everything as default. Okay, so let's go back to repositories, INE VIRL, under our specific path, so advanced troubleshooting, and then we're going to quick launch. Okay, so you should see the page is going to return here, and that shows what are all of the nodes. So in this case, if we look at all of the entries, in this particular topology, there's 25 nodes. So there's 20 iOS-V router instances. There's 4 L2 iOS-V, so the Catalyst iOS code, and then the management box, which is the LXC. Now you'll also see that when you go to the overview, depending on what particular physical machine that you chose in your packet deployment, that's going to control ultimately what the processor resources are, what the memory resources are, and then what the disk available is. And if you just go to the main page on packet.net and then go under pricing, this is what they talk about, the different types, or basically the different variations of the servers that they have available. So in this particular case, we're running on a Type 1 machine, which is 32 gigs of RAM, 4 physical cores, and then it's 40 cents an hour. So if you were to modify in terms of your settings.tf file, which again, if we go back to my text editor here, This is what it's talking about here, which is bare metal _1. So if you were just to change this field to _3, this then would have 128 gigs of RAM and then the other resources that we see. But you'll see realistically, even if you're running about 60 nodes, you don't need more than 32 gigs of RAM in order to host the topology. And this really is the main advantage of using the remote cloud-hosted servers versus using a local box, that if you don't already have 32 gigs of RAM on your laptop or your desktop, then you're going to be kind of chugging along trying to load these large topologies. So you'll see it only takes a couple minutes for it to actually boot the process. So right now we're using about 10 gigs of RAM. You can see it's climbing as the other instances are continuing to boot. And then if we go under My Simulations, and then under this specific instance, so the Troubleshooting Labs, what we basically want to wait for here is for all of the nodes to say active, okay, which it looks like most of these are done booting. Okay, so next thing then is once we launch the topology, and we now want to manage it. So how do we connect to it through the CLI to actually log into the routers? Now you can do this one of two ways. You can either connect through the user workspace manager, so from the web interface that we had launched the topology, or you can use the VM Maestro desktop client that you're probably familiar with already running a standalone VIRL instance. So you don't have to have launched the topology from VM Maestro in order to manage it from that. As long as you have the correct credentials for the VIRL instance, you should see that as a running active simulation. So in my particular case here, let's go ahead and open up VM Maestro. Open up VM Maestro locally. And what we should see is that it's going to give an error message. So I have this running on a separate hypervisor. Let's go up to File Preferences. And then under the Web Services, I have a separate profile here that is going to be for the packet instance. So under Active Profile, I have packet. And then if we edit this here, notice that this address here, it's kind of hard to see because it's kind of small. But the address here, this is the one that is internal to the VPN. It's the 172.16.11.254 address. It's not the public address of the actual packet server. So assuming that you keep your guest username and password the same, if you just edit that passwords.tf file, then when you open up VM Maestro, there's no other changes that you need to make. Okay, in my particular case, I had kind of a randomly generated password. So you'll see that it gives an error message here when it goes to connect. So what I need to do is basically change the profile and then copy and paste the guest password that the Terraform script returns back to us. And assuming this is going to work, you can see those icons change to green. And then if we look at under Simulations, you can now see in, let me see if I can zoom in here. It says Troubleshooting Lab 1 with the broken initial configs. Now, the advantage of doing it this way, once you load the local VM Maestro, is that assuming that you already have your terminal software set up correctly, which in my particular case is Secure CRT, which would normally be under File Preferences, and then under Terminal and Cisco Terminal, I have some settings here which basically is going to open up Secure CRT. It's going to open up each of the nodes in an individual tab, and then the name of the node is going to be the name of the tab in Secure CRT. So basically, I can just right-click here under the topology. I say I want to telnet to all available console ports, and we should see here that these are going to open as individual tabs under my Secure CRT sessions. Okay, also assuming that the initial configs loaded properly, we should see that when we connect to these boxes, they're already going to have the configs loaded. So in this case, if we look at like the show IP route, for example, we can see that this box is running OSPF. If we look at like the show MPLS LDP neighbors, this box is running MPLS label distribution protocol. It's basically one of the troubleshooting topologies already preloaded from the RNS workbook. Now, one of the other advantages of this is that instead of when you're running either VIRL locally on your laptop or your own server, or you're running some other virtualization for the topology, is that if you want to switch to another set of initial configs, instead of rebooting the boxes and then reloading the initial config, the only thing that you need to do is basically launch another simulation. And with the current setup, assuming that you have the larger license for VIRL, which is 30 nodes, the packet instance lets you go up to 60 nodes. So if we were to go back to the user workspace manager and then go under repositories, and then back to the INE VIRL Git repo, and then under the workbook, let's say in this case we want to go to Advanced Technology Labs, and then we're going to launch one of the smaller topologies, let's say just basic IP addressing. And we'll click on Quick Launch. And we can see in this case, this topology has 15 nodes. So it's 10 routers, 4 layer 2 Catalyst instances, and then the management box. Okay, if we were to do this again, let's go back under repos. Let's go under INE VIRL. Under the RNS workbook, you can see that there's also a blank topology, which is the 14-node base topology or the 24-node base topology, which is basically just the blank config, as the name implies, of the routers and switches. And then if you want to take some other initial configs that you were already working on, paste them into there, these are going to load just as blank devices. But the point being here is that you can essentially launch as many simulations as you want up to whatever your license number is for VIRL. And if we go back on the Overview tab and then look at the utilization of the servers, you realistically don't need more than 32 gigs of RAM to run whatever possible topology or topologies that you want within our scope. So in this particular case, if we go back to my simulations, the first one here is running, I believe, 14 nodes again, which should be the routers 1 through 10 plus 4 switches, and then the management node, which doesn't count against the licensing count. Then if we wanted to manage these as opposed to from the via Maestro, which I did in my previous case, you could also just directly connect to them through the user workspace manager. So if you want to open up just an individual telnet window, you can do that through the web interface and then just telnet through your web browser, or you can use whatever your local registered native telnet client is, which in this case I have it registered to Secure CRT as well. And so if we go under Simulations, and then under Basic IP Addressing, once the node is actually active, over here on the right, we can just click on the serial port, and then this is going to open up the web console. As you can see, the router is still booting in that case. Okay, the other option is that if you click on here, the telnet link, so the first one is going to be telnetting to the serial port, which is the console. And then assuming that you have whatever your native telnet client is properly registered, the end result should be is that it's going to redirect you to that particular instance, which in this case it looks like this desktop is not properly set that up. But if you're running on Mac is going to do this automatically, that it's going to register telnet links to terminal. I think in Linux there's some other options that you need to set. In the case of Windows, there's a registry hack that you kind of have to do to point your native telnet handler to PuTTY or point it to Secure CRT. But again, even if you don't want to do it this way, assuming that you have VM Maestro running locally, the new simulations that you launch from the web interface are automatically going to be listed there as under the active sims. So same case as before, if you just right-click on the simulation and then go to Telnet to all available console ports. Then in this case, it's kind of confusing because the node names are the same between the simulations, but typically you would only have one of these running actively at a time. Okay, also for one of the enhancements that we're going to be doing here at INE for this, we have some additional automation that we're in the process of writing that is actually going to make the process easier than this. That basically you'll just run a script where you paste in your VIRL license, you paste in your packet API key, and then it's going to load up a menu from your terminal window that you can use to browse through our Git repo. Just hit enter on whatever VIRL topology file that you want to run. It'll spin it up, and then you'll be able to reverse telnet to the machines locally there from the VIRL box. So if you do want to connect to it directly and then manage the box, not from the GUI, but if you want to manage it from the CLI, and let me close some of these windows here. The Vagrant instance that you're running on your local machine will already have a trusted key that's installed in the VIRL instance. So from here, if we were to SSH to this address, so SSH to VIRL at the public address, you should see that it's already going to log you in. So from here, if we were to look at like an ifconfig and then grep for the internet addresses, one of these that you should see listed here is going to be the internal management address of the jump host. So you can see it has a lot of interfaces as part of the automation, but basically if you were to go back to the user workspace manager and then look at under the port assignments, which is these, like 172.16.11.254:, and then the port number, from directly that SSH session, you should be able to telnet to this particular number, and then it's going to land you directly on the console. So technically, you can manage this all in one session, just natively through SSH. And then, like I mentioned, we are going to be doing some additional automation for this later that you won't even need to open up the web interface. You can just choose from here, hey, I want to launch initial IP addressing, or I want to launch full-scale lab topology 3, and then maybe 5 to 10 minutes later, all the initial configs are going to be loaded, and then you could just from here telnet directly to the boxes. Okay, so for some additional links, as I mentioned, if you go to ine.co/viral, Joel and the VIRL team was nice enough to give us a 15% discount. So if you guys don't already have a VIRL license, you can get one there. And then for packet.net, if you go to ine.co/packet, you can sign up for a free credit on their side in order to test this out. Also for the INE Git repo, if you go to ine.co/gitviral, that's where you can download our topologies. And like I mentioned, I am going to be making additional changes to this in order to add other tracks like Service Provider version 4, collaboration, security, data center, etc. And then as long as when you launch your instance, you're cloning the Git repo down, it's automatically going to add any of those new changes that I commit to the repo from my end. And then last but not least, we have the actual VIRL box cutter repo, which is the one that is going to have the scripting interface to actually launch the Vagrant box and run the automation in order to get Packet actually working.
Brian, thank you very, very much for excellent walkthrough. Just want to add a couple of pieces. There were some questions about the methods that Brian was just demonstrating here. So a couple of things. So the system that Brian was using is the 32 gig bare metal 1 system that Packet offer. Okay, you can obviously use the bare metal 3, but one might suggest that's overkill, depending on how many simulations you want to be running simultaneously, as Brian demonstrated. Okay, so the bare metal 1 is what he was using. Brian was also showing the box cutter virtual machine. Now, key thing about the box cutter virtual machine, if you do not have VIRL installed on your local machine, then absolutely you can use the box cutter as a way of bringing up your VIRL instance on Packet. However, if you do have VIRL installed locally, you can do all of the operations that Brian just showed directly from your VIRL instance. So it will talk out to the Packet.net platform, spin up your VIRL server, bring up everything there. And there are tutorial videos on the Cisco VIRL YouTube channel covering both how to use box cutter. So again, a video tutorial showing you the same steps that Brian just walked through. And then also a video that is showing you the steps that you need to do if you want to use the VIRL server to bring up your instance on Packet. So either of those methods is perfectly viable. Brian, just a question for you. With working with the system on the Packet.net platform, when you're spinning up your simulations, what kind of speed are you seeing with bringing up I don't know what the sort of your go-to simulation for CCIE study is and how many nodes are in there, but what kind of bring up times do you typically see?
I would say for the larger topologies, which is about 30 nodes, probably 5 minutes on the larger end. Which if any of you have tried to run this natively, like on ESXi, like running CSR 1000V or XRV on a regular ESXi host, it's much, much faster than that. Typically what we do in other virtual machine type orchestration setups that we've done is that you typically keep the VM running and then not reboot it or not have to roll back to the snapshot. because if you reboot your physical host, it can typically take like a half an hour or more just to get the instance to run. But since in this case the machine is bare metal, there's nothing else that's running on it other than VIRL, which is different than, if you're running it on your laptop or some other sort of, shared hypervisor. It's very, very quick in order to actually start the topologies from start to finish. The only thing that is kind of time consuming is the spin up of the initial packet process. But like I mentioned, since it's automated anyways, you can just start it, go grab a cup of coffee, come back 45 minutes later when you're ready to start studies, and then everything is going to be automatically provisioned for you.
And you're caffeinated.
And you're caffeinated, exactly. Right.
Is there any advice that you would give people in respect to like saving their work partway through, sort of configuration extraction, anything there, anything special that people need to do in respect to operating on the Packet platform? Or
one thing actually that I was thinking of is that if we go back to the user workspace manager, so once you're done with your simulation, and you'll see in the upper right here, there's a button that says to extract configs. Okay, so under the user workspace manager, under my simulations, and then whichever one that you're running, so for example, troubleshooting lab 1, you'll notice that this string here is kind of a unique value that the system is running. It's like a separate instance of that topology file. So if you, when you're done with it and you want to save your configs, you can just click on extract configs here. So in this case, I just selected all of the nodes and then click on extract configs. The ultimate result is that it's going to send you locally the .virl file to use. And one of the things that I was thinking about to kind of speed this up in the future is that you can start your own private GitHub repository, save all your .virl files to that, and then the next time that you want to continue your work where you left off, you just need to download your own repo and then run those particular files. Because again, the one thing to remember is that once you're done with the Packet instance and you tear it down, all of that stuff gets deleted because it is a bare metal machine that doesn't support snapshots like a virtual machine would.
Yeah, that's a very, very key point. I mean, they don't operate like, oh, I think I will just roll back. Like, no, not quite. Okay, another question that people were asking about was I guess it's in respect to coverage, how good the platform is in respect to the various different CCIE tracks. You're busy building the material. What's your view?
Well, in terms of routing and switching, basically you can cover 100%. The way that we had initially written our material for RNS was using CSR 1000Vs and then physical Catalyst 3560s. You'll see there's some minor differences in terms of the switching code, but for the regular router code for the IOSV and the CSR 1000V, you can do 100% of those tasks. In the scope of security, you can do anything that is router related in terms of like LAN-to-LAN VPNs or remote access VPNs. There's also the ASAV, so anything that has to do with the firewall, routed firewall, transparent firewall, site-to-site remote access VPNs, that's going to be covered. Anything that has a virtual machine that is outside the scope of what's already in the VIRL instance, you can also load those separately. Like I saw some people had questions like, how do I talk to an ICE server, for example? You technically could just upload the the virtual machine instance itself and then launch it as a separate connection here. I'm not 100% sure the details about how to do that yet on Packet.net. But I think that might be an interesting topic for further discussion after this. Is how do you take those kind of external virtual machines that you want to run and then combine them with the cloud Packet.net instance and then whatever custom VMs, whether it's ACS, whether it's ICE server, call manager, something like that, to talk to the virtual machines on the other side.
Yeah, I mean that's certainly. I mean, there's certainly a couple of options there. I mean, one is to upload the disk image into your Packet.net system, and yeah, that might get a little bit laborious in terms of doing that each time you're spinning your system up. The other option is indeed to have a virtual machine running locally. If you've got the capacity to do it, and putting an interface from that device. It's a little interesting way of doing it, but basically connecting that in over the OpenVPN connection into your target system that's running up on the network. And that might be a good video actually to do.
You know what technically you could even do beyond that is that you could run like a CSR 1000V and then do a GRE tunnel. You could do OTV tunnel to do layer 2 over layer 3. You could be running virtual machines in Amazon Cloud, Rackspace Cloud, whatever, and then have a connection to them. Basically, as long as you open up the ports in order to do the connection to the VMs, there is a way to expose it to the public network. It is kind of a, some work, Joel, as you mentioned, to get it actually spinned up to do so, though.
Yeah.
So just one comment on that particular thing. It's totally doable to run layer 2 encapsulation and do .1Q VLANs over the OpenVPN. So that would be another way of doing it. And you simply could bring up your ICE or your radio server, whatever you want to run locally on Fusion or Workstation or something, and then have that tied back to your simulation running on Packet.net. So it's totally doable that way.
So just a couple of other pieces here. There's a gentleman, Salvatore, who's asking you, is things like live visualization working? So yes, live visualization will work. Traffic captures will work. All the functionality that you would expect to see on the local VIRL server if you were running that works exactly the same if you're running in the cloud. Even down to the behavior you see in terms of like latency and jitter functionality, all of that works. So yes, there's no real difference between running it on your laptop or on a local server and running in the cloud. So Salvatore, yeah, that live visualization is definitely there. Brian, another question that was being posed was when you're saving configurations, can you actually save those configurations and then bring that back to your own repository and do that within the system? I mean, one of the things is that UWM is not it's a read system. It's not a write system to the Git repo. So any suggestions in terms of somebody who's using Git as part of their study cycle and they want to do that kind of capture and then post, any suggestions or comments as to good tools to use or workflows that people should be thinking about?
I would say probably the simplest way is just to download it to your local machine and then to push your own Git changes back. So in my particular case here for the actual INE repo, it's basically just a local directory that I have here that has all the VIRL files saved in it. And then anytime that I make changes, for those of you that are not familiar with GitHub, basically I'm running the actual GitHub desktop client. Let me go ahead and open this up here. And
you want me to share again?
Okay, let me go back to sharing.
Look at this thing on my desktop that nobody can see. Yeah.
This is my first time using a computer today, Joel.
Caffeine.
Okay, so I have just on my local file system here, this INE-VIRL. So this is the actual Git repository. And then anytime that I make a change to this, so let's say I have a new text file, whatever, test.txt, the Git client is going to know this. So if I look at the changes here, so this is already registered as a repository. And then if I just sync the changes or say commit to master and then sync the changes, if we go back to the remote server and then go under repositories and then just refresh this, and I'm not 100% sure how long it actually takes to propagate the changes, but you can see it's pretty much immediate. So assuming that you already had your own Git repo that you're saving those changes in, and one thing you could do would be just to copy all of our files into yours, because once these are set up, there's not really a lot of changes that we're going to be making to them. So you could have your own directory that you take our VIRL files and then commit them back up to GitHub. And then anytime that you make a change, you could just do the extract configs from the UWM, save those to your local repo, and then push the changes back up. So again, as long as you already have this set up, you just need to go to repositories and then click on add and type the URL here, and then it's going to clone those changes back down. Now, I would assume that also, and this is kind of a little bit outside of my scope, but since the actual VIRL box is running Linux, you should be able to do the Git commit from the CLI. Wouldn't that be true, Joel? Because somewhere on here is the actual VIRL file that the project is running, right?
That's correct. Yes. So yeah, I mean that's being held within the workspace. So yeah, you probably could do it that way.
Personally, I would say just download it locally and then commit it back up.
Yes. Yeah, because the configurations themselves aren't being pulled back into a local storage location.
Yeah.
So I don't think the git commit from the VIRL server itself is going to see anything. Right? It doesn't. It's looking for changes. It won't see any changes.
But again, it's like any of these things. The learning curve is kind of high at first, but once you try it out a couple times, it's really not that complicated. And once you get to this point where you know how the deployment process works, like in my case, what I've been doing is before I leave the house to go to my office, I just launch it from my laptop at home. And by the time I'm ready to actually do work with it, the topology is already ready to ready to launch.
Okay, we're going to be wrapping up there. I would like just to hand over to Valerie. A number of people have been asking about discounts and things of that nature. So Valerie, would you like to just run through what offers are available to people, please?
So we have 2 promotions going on right now. One of them is if you want to use VIRL on Packet, you can sign up through our special link with Packet on virl.cisco.com/cloud. You'll get a $25 discount towards your Packet rental fees. And then another one is our collaboration or a promotion through INE where we have a promotional link through the INE site where you can get 15% off your first VIRL purchase. We will have those two promotion links and details also included when we post the webinar information afterwards. And you guys, if you sign up for this webinar, you will receive an email with all the details as well.
Great, thank you. So just before we finally wrap up, so all of the questions that have been posed, we will be trying to make sure that we get answers for everything. Valerie, how will people be able to get hold of that Q&A?
We'll have the Q&As transcribed on our community, and the link will still be kept valid even after the session, so you can come back and view it anytime.
Excellent. And the recording from the session we'll also be putting out to everybody so they'll be able to take a look at this. And with that, Brian, I would like to say thank you very, very much on behalf of the VIRL team for doing this session today. Very informative and really great to see the kinds of things that can actually be done on a fairly powerful platform that the Packet.net platform is providing for people. Thank you very, very much for spending the time and putting all the material together.
Pleasure as always, Joe. Thank you, Valerie, and thanks everybody for attending. And I hope to see you guys again in further seminars and at the INE online classroom.
Great, thank you. And yeah, look forward to seeing people again for the next VIRL webinar. Obviously, we'll get details out to all of the people via the usual channels, so Twitter, newsletter, etc. So more interesting stuff, hopefully next month. Thank you very much for your attendance. Have a great rest of the day.